Hello everybody. In this video, we're going to look at functions and mappings. So if we begin with one-to-one mappings, this is where each value of x maps onto exactly one value of y. So no two elements from x will map to the same element in y. You can think of this as assigning a unique task to each member of a team. Everyone has their own task, and no two members are assigned the same task. So in terms of this function, we can see this x value is the only x value with this y value. And in many-to-one mappings, this is where more than one value of x maps onto a single value of y. And we can think of this as imagining a song duet where two singers harmonize to produce one unified sound. This is many-to-one mapping. So for instance, this y value, well, many x values, these two, share the same or one y value. So this is many to one. So we can apply these ideas in example 1, where we've been asked to state whether the following functions are one-to-one, many-to-one, one-to-many, or many-to-many. In example A, we've got 4 minus 3x. Well, this is a one-to-one mapping, because you can see each value of x maps onto its own distinct value of y. In question B, we have the function 2 to the power of x. Again, this is a one-to-one mapping, because we can see only one value of x maps onto its corresponding y value. And for question C, x squared minus 6, well, this is a many-to-one mapping, because if we look at one single value of y, you can see many values of x, in this case 2, will map on to this single y value. So this is a many-to-one. And in question D, if we have plus or minus the square root of 9x, well, we have a single x value, and you can see that this maps onto multiple or many y values. So in this case, we have a one-to-many. Okay, so hopefully you've got an idea about the different types of mappings. So this is relevant when we look at functions. And a function is defined as a mathematical function assigns each element in its domain a unique value in its range. If any domain element maps to multiple range values, it is not a function. So in this case, functions only exist if we have a one-to-one or a many-to-one mapping. And the domain, well, the domain of a function represents all the input values it can accept. Often this is visualized as the x values on a graph. So in question A, this would be the domain, the x values. And the range, well, the range of a function denotes all the output values it produces, typically seen as the y values on a graph. So this would be the range here. So in example 2, which of the following is not a function? So for example A, you can see we have a many-to-one function where these many or multiple x values fall on a single value of y. So because it is a many-to-one mapping, it is a function. In B, well, this is interesting because it is not a function here, but it is a function here. So we need to define when it is a function. And if this is the x-axis, it becomes a function from this point onwards. So we can say it is a function within the domain x is greater than or equal to 0. Because this is one-to-one mapping. And for C, well, we have this circle, a squared plus y squared equals 25. And if we look at a value of x, say this one and this one, call it x1 and x2, well, multiple values of x share the same y value. But they also share multiple y values. So this is not a function because it has a many-to-many mapping. So moving on to example 3, state the domain and the range of the graphs which are functions. So in question A, the domain includes all positive x values and all negative x values. So we say x has all the real numbers. And the range starts at 0 and goes upwards infinitely. So we can say f of x, the range is greater than or equal to 0. And for question B, the domain, as we've said here, is when x is greater than or equal to 0. And the range starts at this value of y, which is -5, and it goes upwards from -5. So f of x is greater than or equal to -5. And it can be equal to -5 because the domain starts at 0. Okay? Well, I hope you found that useful. Thank you very much for watching. If you did find that helpful, please like and subscribe. And you can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again and take care.